Hello everyone. We are from Group 2. My name is Armin and my group member is Azona Bicha, Daniel Lee, and Jar Andre. Today we present the open-ended lab 2, which is the study of absorption rate of methylene blue dye on activated carbon. Today I will present my part is from introduction up explain about the problem statement, objective, and the variable. For this slide, I will explain about the problem statement and objective. So our problem statement is to study the MIM to evaluate the effect of the various factors such as contact time, concentration, pH, and the temperature on the absorption efficiency of the activated carbon. And for our objective is to investigate the absorption rate of the methylene blue dye on activated carbon and to compare the experimental result with absorption kinetic model based on the Langmuir and the Freundlich isotope. For this next slide, our variable is for manipulated variable is the effect of the methylene blue dye during after time direction change, and for the responding variable is the absorption efficiency of methylene blue dye onto the treated activity carbon, and the constant variable is the initial pH of the solution. So that's all for my parts. Thank you. I will pass to my group member.
Here are the following materials needed for this experiment. Coconut shell activated carbon is bought from a local manufacturer. Wash the sample several times and dry them in an oven overnight at 120 degrees Celsius. Grind the samples into a form of fine powder before use. Use methylene blue supplied by Merck as received. The cationic dye having formula of C16H18 N3SCl with molecular weight of 320 and CI number of 52015 is chosen as the adsorbate. For the startup procedure, we start with the preparation of dye solution. Without further purification, use the methylene blue in commercial purity. Next, prepare the dye stock solution by dissolving accurately weighed dye in distilled water to a concentration of 500 mg per liter. Obtain the experimental solution by diluting the dye stock solution in accurate proportions to different initial concentrations. Next is the preparation of treated activated carbon or TAC. We use the commercial activated carbon produced from coconut shell as a precursor for the preparation of TAC. Use the chemicals potassium hydroxide and sulfuric acid. Dry the granular coconut shell activated carbon or charcoal of about 0.1 to 1 cm in size in an oven at about 80 degrees Celsius in a week. Infuse about 10 grams of activated carbon with 100 milliliters of freshly prepared concentrated solution of KOH of about 5% to 60%. Next, carry out the infusion at 70 degrees Celsius in a normal bath until the remaining solution is evaporated. Dry the sample overnight at 120 degrees Celsius in an oven and carbonize the infused activated carbon in a horizontal furnace. Then set the furnace temperature at 500 degrees Celsius under nitrogen gas flow for 3 hours, followed by carbon dioxide gas for 1 hour. Cool the resulting TAC to room temperature and then wash it with 0.5 molar H2SO4 to remove any remaining KOH. Analyze the surface area of treated activated carbon using a Micromeritics ASAP 2000 surface area analyzer. For the operating procedure, it consists of the adsorption experiment where factor 1 is temperature and factor 2 is adsorbate concentration. Firstly, carry out the adsorption of methylene blue or MB on activated carbon using a bath experiments method in a rotary shaker at 150 rpm. Carry out the adsorption process with two different initial concentrations of 50 ppm and 100 ppm. Carry out the isotherm study by varying the dosage of the adsorbent with the same concentration of MB solution. Treat each solution of 25 ml with 0.05 to 0.4 grams of adsorbent. Conduct all experiments in duplicate and carry out the controls with no adsorbent simultaneously to ensure that the adsorption is done by activated carbon and not by the container. For factor 2, which is the adsorbate concentration, weigh 30 mg of AC1, AC2, and AC3 respectively. Perform all batch adsorption experiments on a thermostated shaker SHAC with a shaking of 120 rpm. Maintain the system under shaking at 30 degrees Celsius until the adsorption equilibrium is reached. Study the effect of temperature on dye absorbance by adjusting the MB solutions to different temperatures of 30, 40, and 50 degrees Celsius and agitating at 30 degrees Celsius for 8 hours. The formula of MB adsorption on activated carbon is Q equals CO minus CE times V over M. For adsorption isotherms, the Langmuir isotherm is strictly applicable to monolayer chemisorptions. The well-known Freundlich isotherms is widely used to describe adsorption on a surface having heterogeneous energy distribution. Test the experimental data with respect to both of these isotherms in the following formula below, where Qm is the equilibrium adsorption of activated carbon, Mg over G, Kl is the Langmuir coefficient, L over Mg, and Kf is the Freundlich coefficient, L over Mg. Then determine the adsorption isotherms using different concentrations of dye, which results in an equilibrium concentration. Then calculate the absorptive capacity and also devise the adsorption kinetics curve.
For the safety precaution, the focus is on the chemical handling. First, wear the PPE such as gloves, goggles, and masks while working with the chemical. This is to avoid direct contact with the chemicals. Second, the chemical should be labeled properly and keep it in a well-ventilated area such as fume hood. Last but not least, any waste created during the experiment should be disposed properly according to the lab rules. That's all from us, Group 2. Thank you.